My name is Dennis Batlov, and I'm based out of Seattle. I am a worldwide tech leader for AI/ML, which practically means I help organize the work of, at this point, hundreds of specialists in AI/ML who are coming out and helping customers build AI/ML applications on AWS. And additionally, for the last few years, I've been leading responsible AI for the field, even before generative AI came on stage. It was clear that this is an area that requires some additional work, both from the science point of view, engineering point of view, and just generally understanding and kind of what and how to approach this topic. Now I also lead a team that is taking responsible AI as one of the key kind of considerations from the science, model evaluation, and so on. I've been also personally participating in ISO and European equivalent Sense and Elect standardization efforts around responsible AI, so contributed to explainability standard, transparency, bias, and others. So with me today, I have Matt Frey, who is the Director of Software Engineering at Cisco, and later on he'll come on stage and talk through the responsible AI journey that Cisco had. Great, so let's get going. Obviously, generative AI has shown tremendous sort of potential. It's a step change in capability for machine learning. And yet, we see a number of new risks and challenges. Like some of the existing ones are still there, and we'll talk through some of it too. But certainly with generative AI, there's a whole slew of new issues. Some of those are really, around hallucinations. We've seen so many, pictures popularized with maybe, not having the right number of fingers and so on. And there's definitely been a great deal of improvement on that front. But we still see an occasional issue crop up, even if the numbers are right. You may have seen this circulating on the internet as one of those examples. So what is the reason that we really have all these generative AI issues? And quality is just one of them. But one important distinction between traditional ML and generative AI is that the models, the foundation models, are broad and kind of allow for many different use cases. And the other, of course, difference is that now you can literally take an off-the-shelf model and start applying it to many, many different use cases. Whereas with traditional ML, an example of like consumer lending, you will have specialized training data, you will build a model that's doing just this one thing, and therefore it's much easier to sort of appreciate or understand the risks that are involved. And certainly the risks are many. We've seen a number of things in the news. And so again, just as a quick reminder, often lawyers, for example, search for case law. And it's very easy to use these generative tools, but of course, again, hallucinations arise, and it's amazing that it hasn't happened once, but actually several times. In fact, this is a different case where somebody did the same exact thing and tried to come up with a fake case. And sometimes things are not just about hallucinations, but maybe overall quality, because if a chatbot is incorrectly interpreting a policy, right, then it's easy to for users to make assumptions or make mistakes, and of course these could be quite costly. And a more recent one is in the transcription of kind of AI or AI transcription of medical kind of summaries. And you can imagine that if hallucinations crop into this, it could potentially be quite dangerous as your care team is reviewing the notes from previous interactions. Some of us are able to filter these things pretty quickly because these transcription mistakes could be obvious, but occasionally those actually could be quite difficult to filter out, and mistakes could arise. But there are some applications where hallucinations are actually very welcome, and so This is one of them. Obviously, this is where hallucinations are quite welcome, in fact. But okay, let's talk about these emerging risks and challenges with generative AI. We've talked about veracity because it's about hallucinations, factual correctness, kind of higher level quality of the output. We'll talk more about intellectual property and data privacy, but toxicity and safety is really a new one, because now the language that is generated could contain things that are really hateful speech, threatening, insulting, kind of demeaning to maybe an individual or group of individuals, right? And so it's very important foundationally to get that right, obviously. But there are some interesting situations where, depending on the exact use case, you may allow some of it, right? So for example, if you're quoting a person, or maybe it's a passage from a book that was written 100 years ago and could use a different language, and this is factual, this is just what it was, and certain examples or certain situations should permit this kind of thing. And then, of course, you have some other kind of questions that you may consider as sort of out of scope for these chatbots. We'll talk about denied topics, for example, later on. So that's that. Okay, so responsible AI, you hear a lot about it, and sometimes it's unclear. What is it exactly, right? How do we define it? And different organizations may define it slightly differently. The way we look at it is as a number of interrelated concerns, often interrelated, but in these 8 pillars of controllability, privacy and security, safety, we talked about toxicity, bias and fairness, right? Veracity and robustness, explainability, transparency, governance. You may notice that sustainability is not on the list here, and that is because it's usually treated for us as a AWS-wide kind of concern, separate, but oftentimes it's also lumped into responsible AI considerations. So my intent here is to actually go through some of these pillars here and talk about specific tooling and technology that is available to address this. So, but first, I want to talk about AI risk and assessment of that risk, because a lot of the regulations that are coming out, right, certainly if you look at EU AI Act, for example, they look at risk first, right? Let's figure out, is it prohibited, is it high risk, is it kind of low risk type system? And so it's actually important to build that capacity or build that capability in your organization. Ideally, you should actually be assessing the risk before you start building your project. So we've started helping customers, especially in situations where you may not have like an already well-established risk management process, or maybe you don't know how to do this for AI. We started advising customers on how to do it. We've run a few workshops. And in fact, later today, there's a repeat session in Caesar's forum, not Palace, forum, at 4 p.m., where there's a chalk talk that goes through the process of this kind of risk assessment over a hypothetical kind of application and use case. But one way to look at it is to start somewhere, right? And usually what you do is you identify all the stakeholders for your AI system. Then you figure out what does the different severity level mean, right, for your use case. And the likelihood of occurrence of harmful events and the severity of these harmful events, right? So you start ideating, enumerating these harmful events that could happen. And that's where you probably want to bring different people from sort of different diverse perspectives into this mix. And the tooling can actually help assess likelihood of these situations in some ways, like toxicity scores and so on. So last year, we've had this first sort of chalk talk on risk assessment. We published a blog post, and again, so we continue helping customers in this respect, as this is definitely an important way to start things. Cool. So let's start with fairness, bias and fairness. Actually, my favorite topic, I could easily talk about this for probably a couple of hours. But now, what I'd like to say is, like, if you want to assess bias or detect bias in, say, a traditional machine learning setup or decision-making systems, then in some ways, if you have the right data available, it is a technically solved problem. So in fact, with Amazon SageMaker Clarify, we've had bias detection library for quite some time now, and it supports 21 different metrics for bias. And there's a white paper that explains what these metrics mean. This library actually is integrated in SageMaker, but it is effectively an open source library. So you can run it on your laptop if you want to explore how this works. And one of the difficulties here, well, I said 21 different metrics. Well, why so many? Right? Well, the interesting fact is that there's not a single definition of fairness. There's not a single criterion of fairness. There are actually several. And the challenges are often not in technology, but in actually being comfortable with making a decision and saying, I'm pursuing this definition of fairness. And by doing so, you may actually become unfair according to another criterion, right? And you need to be comfortable in making that choice, because there's no free lunch there. Like, you have to make a choice, and oftentimes this comes in, you have a trade-off between accuracy and fairness as well, right, that you need to consider. And so once you decide what fairness criterion you're optimizing for, you can then figure out what bias metrics are appropriate, whether it's for pre-training data, for actually once the models have been trained, and so on. And so we've published this blog post to help people with making that decision. Like, what are the default metrics that you should choose given the particular fairness criterion that you're trying to optimize for? But when I said this is solved in terms of technology, like I said, there are many other additional considerations here. For instance, a lot of the fairness metrics are essentially group fairness metrics, which means you're optimizing for group fairness for some demographic, right? And in doing so, you may actually make it fair for the group, but unfair for one member of that group, one specific member of the group, which is kind of odd. And in fact, most laws are formulated in the way that you're not allowed to discriminate a person based on various attributes, right? But there's a challenge. And it's not like you will necessarily make things unfair for some individuals, but it is something you need to consider. And the other thing is, there's also Simpson's paradox, and kind of many different issues like that. But you shouldn't wait, right? Because these issues prevent you from making progress, right? Start somewhere, see what you're getting, and progress from there. The one interesting question is, how does it all relate to generative AI, right? Because I've talked about the decision-making system, the other issue is, for example, if you want to measure bias, you need to know what the demographic attribute for a particular individual may be. So if it's race that you're kind of after, well, in many cases, you're not allowed to collect that information about your users, your customers, right? So you just don't have that data. And that's part of the problem, that you need to either figure out how to impute some of that information or how to get that data right. And in fact, we see, for example, in EU AI Act, there's already some provisions that specifically allow for collection of these sensitive attributes for the purposes of just measuring, right? Not, of course, for any other use like that. And then, okay, going back to the generative AI case, the one thing that I want to highlight here is, as much as we care about the language of the chatbots, right, being sort of not offending us in any way, right? That's clearly a foundational requirement. But I would like to see the industry move towards more of an outcome-based assessment for fairness. And this is possible in the same exact way with these generative systems, because, you know, I want to know whether my system is somehow biased in making decisions, right? Did this person get the refund that they wanted, right? Did that person get the loan approved? That's the outcome, right? And this is still a decision, and you can measure that, and you can still figure out how your systems are doing according to this. Anyways, so moving along to explainability. Another interesting topic. So historically, and okay, very important to not confuse it with transparency, because explainability is about how this machine learning model actually arrived at the output that it did, right? And so understanding that, as opposed to maybe just understanding the fact that that AI system is based on a specific foundation model or a specific algorithm and so on. So again, when it comes to traditional machine learning, the standard approach has always been kind of model agnostic. It's convenient because it doesn't matter what the model inside of it is. You're trying to perturb the inputs a little bit, and you're seeing how much the outputs are affected as a result. And in that case, you can try to build a mental model of how this opaque system is actually behaving by noticing how the perturbations affect the output. And I can give you an example later. But here is an example of how this was computed, and I'm showing you a screenshot from SageMaker Canvas. But again, this explainability is built in SageMaker Clarify as well. And here is a model for colorectal cancer survivability beyond sort of 5 years as a standard kind of metric. And we could look at the high-level model, global kind of explainability, where we say from sort of feature attribution sense, summary stage of cancer is the most important attribute. All right, then age of diagnosis is the next one, and so on. And you can even look at the distribution for age, saying here the unfortunate reality is that the older you are on the sort of x-axis, the less of a probability of you surviving beyond 5 years. And so it goes to like your 80s and 90s of age at the lower right corner. And of course, you can also then examine the explainability of an individual prediction. In this case, there's a predict button. I don't know if you see it, but at the top. And you also see that maybe for this specific patient, the primary reason for the decision is actually not the summary stage, but it could be age or something else, right? So that's sort of traditional machine learning. But this approach can also solve for situations where the generative systems are used for classification, which is one of the common use cases, just like it's better technology to do a classification with Gen AI systems. And so one of them could be text classification. For example, the analysis of these customer reviews for their sentiment, right? And what you could do there is the individual words or sentences or phrases are your features, right? And so you could try to perturb the input by eliminating some of these features and seeing if you still classify the resulting review as positive or negative, right? And that's how you could say, well, these portions in green or darker green are more conducive to decision one way versus the red ones that pull the decision into the other direction. And interestingly, you could do the same thing with images for image classification. In fact, this is a very well-known article or a paper where they built a model that distinguishes huskies from wolves. And the model was not working very well. In fact, many huskies were sort of misclassified as wolves. And they were trying to understand how that works. And so this approach is called LIME, where they actually realized that the model is not looking at the animal itself, but the snow in the background, and making a determination that that's a wolf, because there are a lot of pictures of wolves with snow in the background in the training data set, right? And that's how this was done. And so this is also supported by, say, SageMaker Clarify. And so here's an example where the way it works is you may have an image of a pyramid. There's a classification that's a pyramid. And to figure out what portions of the image are influencing that decision, we, instead of looking at individual pixels, which you could also do as features, right, we look at superpixels, entire regions where the image is split into segments. And then some of these segments are replaced with random noise, right? And you create many such versions of this image, perturbations. And you then see how the ultimate prediction is affected. And eventually you build a heat map, and you could see that in this case, it's sort of the sides of the pyramid that are darker blue that kind of tell you that these are the portions of the image that are kind of supporting the prediction that this is a pyramid. And in this case, it sort of helps us understand that the algorithm may be working in the way that we think is sort of matching our expectations. All right, what about generative case? Well, things are a little bit harder for generative case because, well, the same model agnostic Shapley values or SHAP algorithm, and I forgot to mention that's the algorithm that's used in SageMaker Clarify, kernel SHAP. You can actually use it to predict the generations of certain words based on the inputs. But usually we don't care about generation of a single word. You really want to figure out like why an entire completion was generated. But again, for classification, one trick is you can actually ask the model how it arrived at that decision. And of course, so in this case, it would say, you know, this is a particular email, right? And therefore, you know, I could categorize this as other product usage question. So it's actually correct, but as you can imagine, such explanations could be hallucinatory themselves, right? And so you can't rely on it as like a solid case. The other approaches that we've seen with, say, agentic architectures is that as these agents build plans of action via like chain of thought, say React paradigm or some others like tree of thought, whatever, that plan of action is a kind of explanation, right? So you can record it and you can then audit it later on and see why an agent did a certain thing in a particular fashion. And we'll talk maybe about some other examples of such things in a moment. All right, one last thing I wanted to say here. Oh, so I should point out that for Gen AI, explainability still remains like an active area of research. And so it's hard to come by like ready tooling that's easy to use. So some approaches are looking at the internals of these transformer architectures and models and understanding maybe which specific portions of that neural network is actually triggered, right, when a certain concept is presented. But it's harder to translate that approach to like model agnostic situation where you switch from one model to another and now whatever you've done doesn't work anymore, right? And so there are some approaches where you could do this, but it's still, like I said, an area of active research. This slide here, I'm trying to basically say, look, the reason we care about bias, fairness, and explainability for these AI systems is because they are perceived as sort of non-transparent, very complex, hard to understand. And if they are not functioning correctly, they could scale these injustices, right, to a massive degree. And so we definitely want to prevent that. But I just want to remind people, actually, it's not just AI systems, but there are very simple decision-making systems, such as this, right? Like you have to be this tall to get on the ride. It's an if-then rule, right? Very simple decision system. But where is the explainability of, like, who came up with that cutoff? Right? What are the trade-offs that were used? I mean, obviously there's security considerations, safety considerations, but also probably cost, right? So maybe you could have allowed for smaller kids to ride if you've invested a little bit more into the safety of the ultimate product. But again, we don't know, right? And we cannot get access to it. So just as an interesting kind of, you know, thought-provoking thing, right? Like, if you have organizations, governments, legislations, right? They're making decisions. And in some ways, a lot of the technology, especially for like bias that we talked about, could actually be used to assess the fairness of these systems for different demographics, and it's just like not pursued typically today, right? Just something to think about. Cool. Another one is controllability. We talked about it earlier. So clearly, you need to monitor the systems, and so this is about observability. We had earlier this week a talk with my colleague from CloudOps space on how to do observability with Gen AI. This is posted on YouTube now. But in terms of steering AI systems, they may be interesting features here and there. And so, for example, with Bedrock agents, if you have an action group defined, and these agents choose to perform that action, well, some of these actions could be basically non-idempotent. They could have side effects that are serious. In this case, hypothetically, like something is deleted, right? And so here, when the agent decides to choose this action, a user can intervene and say, I want to allow or deny this action. And so this could be configured in the Bedrock agent configuration. Just one example of how this could be done. Cool. Privacy and security, clearly a very important topic. And here, I just want to remind folks that, first of all, for us with, say, Bedrock, we have a very clear promise that you're always in control of your data, which means that actually, we're not using your data to improve any models, to improve our models, to improve third-party models that are available on Bedrock. So much so, we actually don't store the prompts and completions that flow into these models. In fact, in the early version of Bedrock, in the console, you have a playground, and you can kick the tires of certain models. And just like in ChatGPT, you could kind of put a prompt, and it records the history of your prompts and completions just for your convenience. And then we realized that, well, that's actually diluting this message. It looks like we're storing something, even though this was only done in the playground, right, not for any production use. And so we deleted that capability just to not confuse the customers. Like, by default, your data is not stored anywhere even, right? Now, you may want to store the data for your own sake and like log it somewhere, and there is a way to configure CloudWatch, for example, to put those into, say, an S3 bucket that's under your control. But that's your choice, right? And then you control that fully. And yeah, furthermore, you choose a particular region with which you operate, and then, of course, the data doesn't leave that region as it's flowing through the system, through the model to produce the completion. Now, we do have a feature called cross-region inference with Bedrock, but by default, it's off, and so you need to configure it. In that case, you allow for a different region to be used in case of capacity issues or throttling and so on. But again, none of it is happening by default. OK. And of course, there's also standard kind of table stakes for AWS. We have encryption in transit, encryption at rest. You have, you may create a custom model. And the data that's used to create that custom model is, again, likewise, not stored anywhere. You put it in S3 initially. It's your own bucket. It's done. It's used for training. And once the training is done, like, the data is not needed anymore. So you can do whatever you like with it. Of course, the models that you create in a custom way is also only accessible to you and nobody else. And so I can kind of go on, but I think you're getting the message. And there's also access management. And additionally, there's a way for tracking usage with CloudWatch, troubleshoot issues, monitor API activity with CloudTrail, and likewise, various sort of compliance regimes are available. All right, so now we're moving more towards sort of additional considerations that are heavy or that are of importance for generative AI. So we talked a little bit about safety, toxicity, talked about veracity. Robustness is really about making sure that small perturbations to the input do not lead to massive variations in the output, right? You want the systems to handle such changes graciously. And so here, one of the things that you need to be aware of course, is that every time you choose a specific model, there are all kinds of built-in protections already. There's a lot of guardrails that are just built into the model itself. Usually they're not configurable in any meaningful way, except for some hyperparameters, maybe like temperature, top P, top K that you're passing, and so on. But it's important to understand what are these internal guardrails that these models have. So, for example, with like Titan Image Generator, if you try to ask it to generate an image of Baby Yoda, it will actually reject it from the prompt because it knows that this is, a copyrighted image. And if instead you turn around and try to trick it and like, hey, I want to generate, a green small animal with pointy ears wearing a sack or something like that, right? Even if it ends up internally somehow generating something that looks like a Baby Yoda, it will actually have another check that will prevent it from being outputted. And so there are all these things that you need to be aware of that are happening. So one way to really assess what these are and how they work is to use the model evaluations. And so last year we've launched foundation model evaluations with SageMaker, Clarify. We also launched an open source library called FM Eval, and the same exact technology has been put into Bedrock evaluations. So here you can use automated evaluations for metrics that could be automated using standard sets, data sets for this evaluation. And you can also choose human evaluation because there are certain characteristics and metrics that, it's harder to kind of automate, such as creativity of the output, right? Maybe one. So you start with maybe default data sets for these, but the real value is when you create your own custom evaluation data sets that are based on your use case. And that's really the only way you can distinguish how a model is behaving for your use case, right? Instead of relying on a leaderboard where as soon as some data set gets published, of course, these models will be optimized and trained on that data set and will perform well. So the key thing is to have your own data set and guard it carefully. So lately, there's been a bunch of new additions to the Bedrock side of model evaluations. And so specifically, there is an interesting LLM as a judge capability that's now available in preview. Of course, if you're using human evaluation, it may give you a good kind of result that's based in kind of several humans may be looking at the same output, making decisions, but it is costly, right? And so if you want to do it at scale, using LLM as a judge could be a good way to start. So here's an example. You can't really see the screen much, but on the left-hand side, you have response 1 and response 2 from the two models, and maybe ground truth on the right-hand side. And so a human would look at it and say, well, I think I like this one more than that, and I will choose on Likert scale. And eventually, you get some statistics that show, hey, well, it looks like model A actually performed much better than model B for me, or vice versa. OK, but evaluations are great. These built-in controls are great. But you still may want some customized guardrails around the application that are use case specific. And you may also want some consistency in terms of how you apply these guardrails, because you may switch from one model to another, but you want your guardrails to remain somewhat resilient. And that's why we've launched Amazon Bedrock guardrails. They have sort of existed for a while now, but the most recent prior to reInvent launch was the fact that now these could be used as standalone APIs, which means they don't necessarily need to work with Bedrock models only. You can apply them to any models on AWS, outside of AWS. You just call these guardrails through an API. And the more interesting thing is also sort of at reInvent is two interesting launches. One is related to image filtering. So now it's not just text, but also images could be filtered. And then the other thing is, of course, the announcement that was made at one of the keynotes on automated reasoning checks. And this is really a big deal because now you're not just relying on sort of randomness of a model to generate the right results. Instead, you're applying reasoning checks, and we'll talk more about that in a moment. So here's how you define the filters. So I'm just walking through a few features, right? You could say, for my prompts and my completions, I want to make checks on hate speech, insults, sexual content, violence, misconduct even. And then you can also say, well, I'd like to configure that for images. And then there's also a prompt attack capability that lets you automatically detect certain well-known prompt attacks. Then you have denied topics. So you can actually configure 30 different denied topics, which are effectively out-of-scope conversations. You're saying, I don't want my chatbot to ever talk about politics, to ever talk about investment advice, whatever you'd like to be blocked, basically, right? Because you're building this chatbot for your customers, you're paying for it, right? And so you don't want it to talk about things that are completely irrelevant or maybe even off brand, right? So you program it in English, you define this in a natural language, and it's kind of fascinating to see. You give some examples even, and there's a classifier, there's an LLM that will make these determinations. You have, of course, also PII detection, and if you have some specialized PII, you may even use regexes to define it better. You have profanity filters. There's a standard list. You can add your own words that you want to be blocked. And prior to automated reasoning checks launch, we've launched this contextual grounding and relevance, which is super important. It's a first level of defense against hallucinations. So for RAG applications, you build a context. You retrieve a context. And this classifier will check whether the completion that's produced by the model is actually grounded in that context. And then additionally, you would check, or you could check using this, whether the output is relevant to the question asked, right? It may still be grounded, but not relevant, right? And you want to detect both of these situations. And we'll talk a little bit more about automated reasoning afterwards. So one last thing I wanted to talk about here is transparency. And, well, there are many different considerations here. So one of them is, for example, knowing that the output or some content that was generated is actually AI-generated content. And Amazon joined C2PA steering committee, and the image generation models like Titan Image Generator, the Nova Canvas model that was announced earlier this week, they all contain invisible watermarks in the image. So if you could crop the image a little bit, you may still actually have the watermark, and it would be able to detect that that's AI generated. But more importantly, as a more stronger kind of defense, is you have an actual credential, digital signature attached in the metadata, and you can verify it using tools. In this case, you can see this image was actually generated by this model. And of course, broadly, we publish the so-called AWS service cards. That is our transparency statement. We talk about which, or how the model was trained, how it was benchmarked, what it should be used for and what it shouldn't be used for, right? And with the Nova models as well, we do have a technical report separately that goes even deeper into the details of this. And so usually customers come to us and say, well, can you give us some additional information beyond this to help us clear the usage of the models in our company? And so we often answer additional questionnaires and happy to provide those to customers to go through the regulatory situation. And so with that, I actually would like to welcome Matt on stage, and he will talk about Cisco's responsible AI journey.
Thank you, Dennis. All right, I'm the other speaker. You'll recognize a lot of the facets that Dennis mentioned in the responsible AI tools in Cisco's processes that we've adopted to apply that responsible AI process into how we're approaching AI in our business. There we go, green button. So I want to start, I'll start with a statement, and I'd like some hallucination detection on this. Cisco is in the business of building bridges. True or false, right? Maybe there's not enough context there. Rhetorically, yes, Cisco's, our vision is actually to build bridges to connect humans. We believe that when we connect people, that amazing things can happen through those connections. And so part of our vision is building bridges between people. Cisco's best known for our networking solutions that ensure connectivity between people, across the world, right? Cisco's collaboration group, we offer software suites that provide connectivity internally with your teams and then externally with your customers, the WebEx suite and the contact center suite. And so when we say Cisco builds bridges, yes, here, let me start here. So we do, I work in Collab AI. So in this collaboration business unit, we do connect customers internally with their teams and externally with their customers. And so Collab AI is a group central to Cisco Collaboration Business Unit, where we provide AI functionality to the other product teams who want to integrate AI features into their products. But we sit at an intersection of product managers who would like to solve their customer problems, the engineering teams who want to take AI tooling and capabilities and use those to solve those problems, and then the centralized Cisco policy that governs how we develop AI features. And so every day I do, in my role, I have a front seat at how responsible AI works within Cisco. So I want to start, we'll just go over this very quickly. These are some of the areas that my team has some interaction with, and we help, again, we build out AI functionality to help in the customer experience space with contact center, the WebEx suite, where you think of meetings or calling, messaging, that type of interaction between teams. And then in the office, if you're in an office with a conference room and you're using conference hardware, that's our Cisco devices. We also develop and deploy AI models that run on those. And I'll go into some of these in a little more detail later. So I'm going to start with how we started our responsible AI journey, right? This is probably familiar to a lot of people. Cisco, along with many other companies, when ChatGPT was released, restricted access to the generative AI models and products while we developed internal processes and workflows to decide how to manage procuring and using those products within our business. Right. Even though we already had a responsible AI workflow in place previous to generative AI, the rapid adoption of generative AI and the scope of it, it's in everything and every function across Cisco, right? And so that change in scope introduced some challenging problems that we had to work through. So people across Cisco needed different types of access to even the same model. You might be wanting to use it for different purposes. So we had different use cases and needs across Cisco. Some people wanted to take LLMs and apply it to internal workflows. Other people wanted to use these AI advances and put them into products that we're selling to customers. And then even other people, there's research departments at Cisco who were using previous generation language models and just wanted to continue the research, and were kind of paused, right, while we sort of figured this out. Satisfying all these different needs responsibly required a tight collaboration between groups that didn't always need to work closely together. So like legal, privacy, procurement, IT, the engineering departments, right, marketing and sales, they all had kind of a stake in this. And yeah, so we had to form sort of a central team to help understand the needs of these different parts of the business. And then part of the issue was that many of these groups didn't really have previous experience with AI technology. And so there were a lot of misunderstandings. I'd say if you go away from anything, if I can convey anything here, it's education. When you're starting to make responsible AI policies, have some education. You don't need to know deep details about calculus and how machine learning, functions under the hood, but understand the differences between an off-the-shelf model that is being used for inference. Like, understand that that model is not learning if you're just running it through inference, right? There are different ways of using a model. There's training, evaluation, inference, and the people who are making these policy decisions really do need an understanding of the differences between those uses of this technology and how that impacts like customer data, that's safe ways to use data or using these systems, right? So we did eventually succeed. We now have a robust process for assessing 3 main classes of AI. And I would categorize those as, one of them is products or services that we use at Cisco that our vendors are adding AI functionality into. So we're using something and then there's a release and all of a sudden we've got AI assistants in all of our products. So we need a good way to determine if those are appropriate for our use at Cisco. Right. The second category is internal use cases. So we have like documentation that we want to build bots to help us search easily, or internal workflows that we want to streamline. Right. The third case is when we want to take a product that we are providing to a customer and integrate AI functionality into that for our customers. That use case is actually what I'll focus most on here. That's the one that I'm most familiar with. In our collaboration BU, that's where our team works with our product teams to integrate those AI functions. All right, so I'm going to go back to bridges. I view Cisco's Responsible AI program as somewhat of a bridge, like connecting users or employees in Cisco to AI, right? How can we do that safely, securely, ethically? There are 3 parts that we assess, and I'm going to look at the foundations, the infrastructure, and then kind of the end-to-end, the road of the bridge, if you will, the user experience is end-to-end. So first we'll look at foundations. These I would call the models that support everything that's built on top of them. These are the machine learning models themselves. So some of these models we develop in-house. Others we procure from third-party commercial vendors. Other models, you're aware, are available open source. You can just download them and use them. All right, so there are different sources of models. So my team, we work across a broad spectrum. Natural language problems. So for these, we use language models like LLMs. Are obvious. We have other like language classifiers as well that we use for certain cases. There are computer vision models that we use. So in a WebEx meeting, my team provides the capability to turn on background blur or gesture recognition inside of meetings, or AI-enabled relighting. So there's some features there with computer vision models. We do audio and speech models as well. One of my favorite features in the WebEx suite is background noise reduction. And I know all the collaboration services have this, but I have 3 kids and a dog at home, and I appreciate this feature. And there's also all of the NLP features here are powered by what I would call a speech model, which is ASR, automatic speech recognition. And these do the transcription of audio to text, and then downstream we can further process them with NLP models. So when we look at models, we want to take a look at a few different aspects. One of them is the intended use and the evaluations of this model. So we want to take a look at why was this model developed? What was the problem that it was trying to solve? What's it trying to classify, right? You want to make sure that you understand why a model was developed. You want to understand your sources of training data. So internally, models that we develop ourselves, this is pretty easy to do because we know the training data that we've used. External models, it's a little harder. If you have a commercial vendor who's providing a model, or if you have an open source model, we actually have a process where we make connections with those companies and have an assessment that we ask them to fill out so that we can get a better understanding of how they source their data. Is it ethical? Is it legal? Was it annotated ethically? Right. Known biases or edge cases. All models are statistical. They don't handle everything 100% accurate, right? And so we want to know, it's not that we can't use those models, it's that we want to know the edge cases of where it's appropriate to use those models. An example here that we ran into is some smaller large language models will exhibit a tendency to repeat words over and over. Sometimes those words aren't very polite. They're trained off the internet. So it's not that, again, that we can't use them, it's that we want to understand this behavior, document it, and be aware of it in our use cases. And then lastly, we do need to go through licensing and legal contracts. So a third-party vendor, we need to negotiate with them the use of the model. With open source models, we need to understand the licensing terms of it and make sure that's appropriate for our use, both for like our internal development and then for commercial use as well. I'm going to go on to the vendor assessment. This I would call maybe the platform that's surrounding the model. There are a few different ways that we use models. Some of them we host ourselves, some of them we use managed solutions such as Amazon Bedrock. Amazon SageMaker gives us a little bit more control over where the model's running, how it's configured. And then we also, in our team, we do self-hosted models where we're managing the infrastructure completely ourselves, bring up some GPUs, throw some models on there and operate them. This assessment is actually more focused on the fully managed solutions like Amazon Bedrock. So this usually looks, this is very similar to like if you're assessing a third party that's managing your data somewhere or you're using a cloud solution. The assessment's pretty similar. We want to know things about data privacy and security. Some platforms do. You have to opt out if you don't want them to use your data or have a contractual agreement. So you want to be certain your data is not going to end up training or fine-tuning a model and make its way out into the public at some point, right? So we know how data is handled in the system. Does anybody have access to it? Is it persisted anywhere, right? We want to make those guarantees to our customers that their data is not landing in somebody else's computer or laptop, right? We want to look at the availability and support for the model. Is it available in regions that we need to serve our customers? And this changes over time as data centers are built out and models are deployed in different regions. One major thing that we need to consider is the life cycle of models. And this is similar to any software. If a model that we depend on for a feature that we're delivering to our customers is deprecated, and it will be deprecated, right? The market changes so fast. You can't depend on a model that you're using today to be here in 2 years, right? So we need to know, like, how long will we have when it's deprecated? But there is a process that we need to go through to change to a model while keeping our customer experience the same with what we expect of that model, right? We also look at content moderation. Dennis mentioned a few areas where guardrails are in effect. Sometimes it's built into the model. Sometimes the platform imposes content moderation external to the model, but you don't necessarily have configuration over it. So we need to understand if that content moderation is in place and how we can configure it to our needs, or if we're able to. And then ownership of generated content. This is a little bit of an edge case, but I think the biggest impact for us here, there's like 4 different parties involved in here. There's our customers who are purchasing the Cisco product using the AI feature. There's Cisco, who's developing the feature. There's the provider of the platform, and then there's the provider of the model. So there's like all these parties, and generally, the person who's paying for the model owns the outputs. But there are some use cases where it's becoming more common to take large, more powerful models and use outputs of those to train smaller models to do specific tasks. And those are cases where we're going to make sure that that's appropriate for us to do, because we're kind of getting into competition with the model that we're using, because we want to replace it with something that's lower latency or cheaper. So we take a look at that. Next, I'm going to go to the final assessment. Let me see. I'll speed it up a little bit. This is the actual end-to-end use case, so the feature itself. This builds on all the information that we've collected so far. We curate and almost make like reusable components out of the assessments that we've done so far. We start by looking at should this problem even be solved by AI, right? As much as our marketing team would like AI everything, there are things that just don't need AI, right? So if AI solution is warranted, are the models that we've selected and the architecture we've chosen the right fit for the problem? We look at potential negative impacts. Could an end user inadvertently be guided into a choice that's negative towards an individual or a group of people, right? We look at data risks. Again, at a broader level, it's not just fine tuning that could expose data. You could also have a RAG system, like Dennis mentioned earlier, where you're getting some data from a system that maybe not everybody who has access to this, AI chatbot should be able to see. So you need to, take those concerns into account as well. End user enablement, and I would almost call this more empowerment, where is the end user who's being given these AI outputs, are they aware that it's AI? Are they able to configure or opt out of this feature if they choose so? Are they able to adjust it? Can they make edits and correct it a little bit so they're almost working more in conjunction with the AI? And can they report any problematic behavior that they see so it can be looked at? Guardrails. Dennis did a good job of showing the scope of guardrails. Some systems need more guardrails or different type of guardrails than others. An open conversational assistant is, it's open to many more types of attacks than something that's a closed loop, and we more control the data flows that are going into the models. And then an overall system overview. So most systems built with AI have multiple steps. And so do those steps is there a chance for compounding errors that could cause negative outcomes for customers? So I'll go quickly into one example. This is a feature we built for our contact center offering called Topic Analytics. We can take a set of customer transcripts, extract the reason. These are customers calling into a call center for help. We can extract the reason of why the customer called in, and then group those together and label them as topics so that call center admins can kind of see why customers are calling into their contact center. So when we look through this, we realize that the end-to-end solution, if we were to completely rely on AI for all the steps in here, there's 3 steps in this phase, and if errors occur in the first phase, it will just compound down into the subsequent phases. And so we decided to shift the UX a little bit, the user experience, and bring a human into the loop a little bit earlier to be able to review, edit, maybe regenerate clusters. So we give the user a little bit more power to almost. It's still better than looking through tens of thousands of transcripts yourself, but it gives the user a little bit more control and insight into the final model that's produced. And I'm going to leave you with one more thing. In the collaboration BU, we've pioneered one more step towards transparency with customers to gain their trust. Every AI-powered feature that we're developing, we're producing these transparency notes. These allow customers to quickly identify any areas of concern they might have with where the data is flowing, how it's being processed, and then they can make informed decisions on whether this AI feature is right for their business or not. I hope that Cisco's experience can help you decide how to apply AI responsibly to your business, and I thank you. Back to Dennis.
Thank you, Matt. Love the bridge analogy. I think it worked really well. So I want to wrap up with just a reminder of the automated reasoning checks that were announced and kind of explain a little bit more how that works. So this is really a kind of an industry-first product in incorporating explicit reasoning using logic rules. And the idea here is that you define a policy in natural language. So maybe you already have policy documents, likely. These policy documents will be parsed and will be turned into an explicit rules that are then applied to kind of validate your completions from the language model. And so in this kind of example, hypothetically speaking, again, we're talking about some sort of, let's say, a unicorn airline. And once you define the policy and once the rules are in place, for example, the rules could be about, or the policy could be about changes to the ticket, right? I don't know if you could read it, but it says, I'm flying to Wonder City with Unicorn Airlines and noticed my last name is misspelled on the ticket. I'm currently in person at the airport. Can I submit the change in person? And the system says, yes, you're allowed to change names on tickets at any time, even in person at the airport. So that's kind of the default situation where the rules have not been validated and have not been applied, right? And so now you can check against specific rules, and automated reasoning says, no, this is invalid, and here's the rule, and here's the reason why. So there's even a form of explainability built into why a certain thing was invalid. A name change is allowed if and only if changes are allowed, if changes are allowed and the submission is valid. The submission is valid if and only if the submission method is email. I guess that's really the high-level process of automated reasoning checks. It's using logic. It's actually using extracted variables as well from that text, so it can reason about them in kind of first-order logic available. So with that, one other thing I would say is, I think currently this feature is in gated preview, so you may need to request access to it if I'm not wrong. But please do, and see how it works for your use cases. So with that, thank you so much. Please don't forget to fill out the survey.